Hey everyone, in this video we're going to learn about what a linked list is and what null means with the help of some Lego. Welcome to the Lego memory model, the internals of our Lego computer. Alright, so let's start off the memory. We'll pop this flag over here, and so far in our Lego computer we have an array. Now there's two very important facts about arrays. The first is that each element of an array is the same type. Here they're all 2x2 bricks. And the second important fact is that all of the elements of an array need to be next to each other in memory. They need to be contiguous. So a linked list is also a way to organize data, but it differs from arrays on these 2 points. The nodes of a linked list don't have to be next to each other. We can spread them out through memory. Maybe we'll pop that over there. And the nodes of a linked list don't all need to be of the same type. They don't have to be 2x2 bricks. If you like, you can have a shark as your final node. But for today, let's stick to the bricks. All right. The great thing about arrays is that if you know where an array starts, you know where the other elements are. They're right next to it. Element 0, element 1, element 2. So the issue with linked lists is that we're not sure how do we get from the red node to the blue node to the yellow node. And this is where our pointers come in. In the C memory model, we have pointers. In the Lego memory model, we have minifigs. The red minifig points to the blue node. Blue node is pointing to the yellow node, and the yellow node has a pointer. Oh, actually, where do we point this to? So we need to find something to point. This pointer needs to point to something which, well, can't be memory that's already being used by other data. And it can't be previous nodes of the same linked list. Well, I've got an idea. Why don't we just point to this empty piece of memory here? Nobody's using it right now, so if we point to an empty piece of memory, this means I'm at the end of a linked list. Well, no, that's not going to work because somewhere later in our code, we might overwrite this piece of memory with something else. We might store something like the Sydney Opera House in there. So we can't use that area of memory. Well, what about this conspicuous red flag that I added earlier? This red flag is a special reserved address in our memory model. We can build close to it, but we can't build on top of it. So it won't be accidentally overwritten by our code later. And that's a really handy thing to point to and say, if I'm pointing to the red flag, that means I am the last node of a linked list. And you might be thinking, I know what this is. That's right. This is null. I hope you found that video useful. In the next video, we'll be talking about how to loop through a linked list and print it. Until then, happy coding.